What's up mga kaibigan? So it's me again, Namsu. So I think you missed me, so I'm here again and again for another lesson to tackle about. For today's lesson, we have ways of expressing the concentration of solution, colligative properties of solution, and lastly, thermochemistry. Let's tackle first the ways of expressing the concentration of solution. So what is the meaning of concentration? It means the ratio of the amount of solute to the amount of solution. We can also look at this in this way. It is solute over solution, or solute is the solution. There are many ways of expressing the concentration of solution. The first one is we have percent by mass. Percent means parts per 100. To get the percent by mass, we use this formula. Percent mass is equals to mass solute over mass solution times 100. For example, if we have 5% by mass sugar solution, it means we have 5 grams table sugar in 100 grams solution. So where did we get the 100 grams? It's because percent by mass, we will use the parts per 100. And it can also be interpreted as we have 5 grams sugar solute over 100 grams solution. Let's do some exercises. What is the percent by mass of a salt solution prepared by dissolving 6 grams of table salt in 50 grams of solution? We need to know what is asked, and what is asked is the percent by mass. We also need to know what is or are given. We have 6 grams table salt, which is the solute, and 50 grams, which is the mass of the solution. If we need to get the percent by mass, we are gonna use the solution which I showed you earlier. We have percent by mass equals mass solute over mass solution times 100. Since we have the values of the mass of the solute and the mass of the solution, we are just gonna substitute and replace the value. Percent by mass equals 6 grams table salt over 50 grams solution. Now we cancel out the units and we are left with 0.12, but we still have times 100 to make it into percentage. So we multiply 0.12 by 100. And we finally get the percent by mass, which is 12%. The other way of expressing the concentration of solution is the percent by volume. It is just like percent by mass, but instead we use the volume. Percent means parts per 100. And the formula to get the percent by volume is percent by volume equals volume of the solute over volume of the solution times 100. If we have rubbing with 30% concentration, it means that it has 30 ml isopropyl alcohol to 100 ml solution. Or in other way, we have 30 ml isopropyl alcohol over 100 ml solution. Let's do some exercises. What is the percent by volume of 25 ml alcohol in 120 ml solution? Of course, we need to know what is asked and what is given. What is asked, we need to find the percent by volume. What is or are given is the 25 ml, which is the solute, and 120 ml, which is the solution. As we all know, the formula to find the percent by volume is percent by volume equals the volume of the solute over the volume of the solution times 100. Since we have the values for the volume of the solute and the volume of the solution, we are just going to substitute it. Percent by volume equals 25 ml alcohol over 120 ml solution, then we cancel out the unit. And we are left with 0.21. Since we are looking for the percent, we need to multiply it with 100. The answer is 21%, which is the percent by volume. In alcohol, the degree proof is usually the one used to identify or to express the concentration of alcohol. To find the degree proof, we just need to multiply the percent by volume by 2. We will use 2 times percent by volume. If we use our previous exercise problem, we just multiply 2 times 21%. So our final degree proof is 42% for that sample problem. There are also many ways of expressing the concentration of solution just like parts per million or ppm and parts per billion or ppb. We also have molarity, molality, or mole fraction. And now, let's move on to the next topic, which is the colligative properties of solution. And what does colligative properties of solution means? It means the properties of solution that depends on the number of solute particles present in the solution and not the nature of solute. There are 4 types of colligative properties. Those are vapor pressure lowering, freezing point depression, boiling point elevation, and osmotic pressure. But for this lesson, we will focus on freezing point depression. Before knowing what is the depression of freezing point, we should know first what is a freezing point. Freezing point of a substance may be defined as the temperature at which vapor pressure of liquid is in equilibrium with vapor pressure of solid. The freezing point of a solution is always lower than that of the pure solvent. Solute particles interfere with the attractive forces among solvent particles. A solution's freezing point depression is the difference in the temperature between its freezing point and the freezing point of the pure solvent. This is the format for the freezing point depression. Kf is the freezing point depression constant and m is the molality, the moles per kilogram. Let's have some exercises. What is the freezing point depression of a 0.615 more aqueous solution of any non-volatile, non-electrolyte solute? We are gonna find the molality, which is the given, that is the 0.615, which is the molality. We're gonna times it with the constant of freezing point depression. The answer is 1.14. Water freezes at 0, so when I subtract 1.14 to 0, the new freezing point is negative 1.14. Now, let's move on to our last topic for this video, and that is thermochemistry. So what is thermochemistry? It is the branch of chemistry concerned with the quantities of heat evolved or absorbed during chemical reactions. Special thanks to Google. Thermochemical equations can be manipulated to give important data about chemical reactions. We can use them to predict exactly how much energy will be absorbed or released by a reaction, which is very important because we don't want any unexpected explosions. There are 2 ways we can use tabulated thermochemical data to calculate the delta H of any reaction. The first way requires that we manipulate thermochemical equations in specific ways, so let's be aware of some rules. First, if the reaction has a particular delta H, the reverse of the reaction will have the opposite delta H, or the same number with reversed sign. Second, if molar quantities in the equation are multiplied by a coefficient, so is the delta H. So if you double all the substances, double the delta H. These are the things we can do to thermochemical data to be able to add equations together to result in a reaction we are curious about. Here's what I mean. Let's say we want to know about the change in enthalpy associated with a reaction like this one, but it is difficult to measure experimentally. We can take other reactions with known enthalpy changes and rearrange them to align with our equation and get the data we want. The first reaction provided has carbon graphite on the left, which is where we want it, but the equations we want has 2 moles of graphite. So let's double this one. We got 2 moles of everything instead of 1, and we doubled the delta H. Next, this other one has CO on the right where we want it, and in the right amount, so all we need to know All we need to do is add these equations together. The O2 and CO2 will cancel because they are present in the same amount on both sides. And we are left with the substances in our original equation. Since we added the equations, we also add the delta H's to get the delta H for our equation. This kind of manipulation is allowed by his law. We can manipulate the coefficients of a reaction or reverse its direction in any way necessary as long as we change the delta H associated with it in the appropriate way. Then we add or subtract the equations as necessary to give us precisely the equation in question. The delta H you get by doing the arithmetic will be the delta H for the reaction.
Thank you for watching my video. Happy New Year!